Hi, my name is Maicon Bernardino. I am professor and researcher at Federal University of Pampa from the southwest of Brazil. I will present our study called Taxonomy of Performance Testing Tools, a systematic literature review. I am recording this video at home in quarantine due to coronavirus. Introduction. Software testing is a key part when developing quality software products. The purpose of testing includes quality assurance, verification, validation, or reliability estimation. In order to balance thin expectations, software projects usually present different points of view in terms of effort, investment in testing. In this sense, empirical works provide many evidence suggesting that time invested in testing save money in software projects. Software performance testing. Amongst many techniques used to test software quality, we can mention as one of great importance the performance testing. By conventional wisdom, performance is a serious problem in a significant fraction of software projects, which causes delays, overlapping, developer exhaustion, deployment failure, and even project abandonment, but these failures are really documented. The purpose of performance analysis is to determine which parts of a product should be optimized to increase its quality. Software performance testing tools. Due to the need to accomplish performance testing to ensure software quality, a number of tools have been developed to automate performance testing. Many different characteristics and particularities that must be observed to justify its choice within a given project. The performance tester must acknowledge and select within the available performance testing tools. An empirical in-depth characterization of performance testing tools on the markets is missing from the literature. Our contributions. This paper presents the results of a systematic literature review. It identifies and categorizes existing performance testing tools in the literature. It also provides an overview of main characteristics and technologies employed to performance testing tools. This study is built on the guidelines for performance systematic literature reviews in software engineering proposed by Kitchen. The objective of this study is to identify and characterize existing performance testing tools in the literature. In addition, we aim at identifying the academic and open source tools and find out their quality attributes. Method. In this sense, the description of the goal is describing according to the goal question metric paradigm. For the purpose of identifying, characterize, with respect to performance testing tools, from the point of view of performance test engineers and researchers in the context of performance test environment. Research questions. The research questions are structured based on PICOC criteria: population, published research on software, intervention, performance testing, comparison, general comparison of the tools, outcome, performance testing tools, contexts, both academic and industrial contexts. Thus, based on Peacock criteria, we formulated two research questions. What are the tools that support performance testing? And what characterize a performance testing tool? Database selection. Formal literature research was conducted using the following databases: ACM Digital Library, Engineer Village, IEEE Explorer, Science Direct, Scopus, and Springer Link. To define the search strings, the terms and synonyms are defined. Term performance test, and their synonyms like that: load test, stress test, soak test, spike test, workload test, automation test. The term tool is combined with synonyms like generator, injector, monitor, analyzer, framework, suite, environment, and plugin. And the last term, software, with synonyms like application and system. For each term, we use a Boolean conjunction operator AND to formulate our string. At the same way, we use a Boolean disjunction operator OR to connect the synonyms. Here, I presented the resulting basis search string used in each digital library. Our selection process was defined in 4 steps. Initial selection, resulting in 1673 studies. Eliminate redundancies, resulting in 1160 studies. Intermediate selection and final selection and elimination of discrepancies, resulting in 146 studies. The last step, quality assessment, we formulated quality criteria to access the study in the last steps, resulting in 53 studies, identifying 38 performance testing tools. Results. Research question 1. What are the tools that support performance testing? The purpose of this question is to map the tools used or proposed by scientific study that support some kind of performance testing. In total, 38 performance testing tools were identified through our SLR. Most of the tools were cited only once or twice, while some of them have been heavily referenced 11 or 9 times, showing a clear presence and greater adoption of these tools, namely LoadRunner and Apache JMeter, the former being a commercial tool, while the latter is an open source tool. Research question 2. What characterizes a performance testing tool? In order to find any problems in software, the main characteristic of a performance testing tool is that it should generate a certain workload on target system suit. These problems may be related to scalability or reliability or any system bottleneck, and this can occur in a variety of ways. Each tool can have unique characteristics in its implementation. However, despite adopting distinct features and strategies, it is perceived that tools developed for this purpose make use of an already consolidated architecture. Approach. Another goal is to explore different kinds of approaches for workload input definition. and determining whether these types of input could be classified into different categories. Three main categories were observed: model-based testing, capture-replay, and manual scripting, in which is presented in the Venn diagram figure. Table 1. This dispersion of tools within these categories is shown in this table and specify which kind of model or scripting language each tool supports. Choosing a tool whose model or scripting language is best known by the test engineers can result in a smaller learning curve in its use and fewer errors when creating testing scenarios. Table 2. The results obtained during this classification were represented in this another table, where it is possible to visualize each monitoring metric. To evaluate the performance of a system, it is necessary to monitor its behavior during workload execution. This resulting in a high volume of data persisted for later analysis, thus making the implementation of a persistence layer necessary. As a consequence, most persistence layers will use external files for persistence or underlying database management systems. So, the file types that have been observed as most common are XML or JSON, respectively. Finally, as for database management systems, no pattern or preferences were identified. A taxonomy is a scientific method of classification according to an established system in a specific domain, with the resulting catalog used to provide a framework for analysis. Any taxonomy should take into account the importance of separating elements of a group into subgroups that are unambiguous and taken together include all possibilities. Therefore, we propose in this work a new taxonomy based on this expensive literature review represented by feature model in that will be representing this figure. Not all features of the performance testing tools represented in the taxonomy were planned to be identified in our initial research perspective, but are nevertheless identified and are represented in the taxonomy. Our taxonomy of performance testing tools is the main contribution of this study. This taxonomy is classified in four main features: input approach, load generator, monitor, and analysis, being the first two mandatory features and the last two optional. Threats to validity. Construct validity. First of all, systematic reviews are known for not guaranteeing the inclusion of all the relevant works on the field. This can be explained by the limitation of the search mechanisms for set of keywords defined in this study and the lack of them in some of the relevant works. In order to avoid this bias, articles not found in databases were manually inserted into the body of knowledge. Internal validity. In order to reduce possibly bias, the stages of selection of the studies and data extraction were carried out by two researchers. The results found by each were tabulated and compared so that any kind of bias could be identified, and when in disagreement, the authors could debate and a consensus was reached. External validity. The use of a well-defined and valid protocol assures that any other group of researchers could replicate this review using the same set of parameters, would yield the same results. The only variable that could compromise this assumption is time, as new research and tools emerge every day. To minimize these threats, the update of this systematic literature in the future is required. Conclusion validity. This research found relative good numbers of focus paper, thus providing a statistical power to drive our conclusions. These could be affected by terminological problems in the search string, which may have led to the absence of some primary studies. For the minimization of these problems, the generation string was tested and the results were previously analyzed in a way that one could not notice the relevance of the same. When necessary, the search string was modified, reduced the threats of not indexing all available content on the web by using 6 digital libraries. Conclusions. This paper presented the results of a systematic literature review. One of the main contributions of this SLR is the conception of a performance testing tool Taxonomy. With this summarization, it was possible to verify that the number of papers published in the area, this number suggests a growth curve from 2040, reaching its apex in 2017. Thus, our conclusion is that the research area is expansive, demonstrating an increase of interest by academic community. Thank you so much for your attention. If you have any questions, send me a mail at Bernardino at acm.org. Thank you very much.